Hi dear students. So in the previous video, we have discussed about the first part of calorimetry, and there we have learned a new thing, that is specific heat capacity. Specific heat capacity. So today we'll learn the physical significance of specific heat capacity. Nothing else. What we have seen in the previous part, that how this specific heat capacity has come. We have seen the heat energy H, or you can take Q, is directly proportional to the mass of the body. H is directly proportional to the temperature difference, that is del T. And if I write it together, H is proportional to mass into temperature difference. So if I want to make it an equation, we have to take a constant quantity C. And this C is known as specific heat capacity. And by that I have told that specific heat capacity is a characteristic of a body, of a substance, which shows the heat absorbing or heat emitting ability of a body. You have given same heat energy to a body, maybe the change of temperature is different for different body, and that depends on the specific heat capacity. Okay, and here C is equals to small c, definitely H by M del T. In some book it is written, it is Q by M del T. So total heat energy, you can take H, you can take M, that is your choice. Okay, it is not like that. What is written in your book, that you have to take. Now we have to learn what is the physical significance of it. What is the physical significance of the specific heat capacity? See here, assume you have taken two substances. Okay, after taking it, you have kept it on fire. Assume this is a substance and this is another substance. You have just kept it in fire. Here is the burner, and here also you have to use the burner, and you have burned it for equal time period. You have burned it for equal time period. So we'll expect that the heat energy you have given to the bodies, that should be same. But when you check the temperature, then there is a problem. Assume it is the point A, it is the body A, and this is the body B. Assume the temperature of body A, that is 50 degrees centigrade. Assume initially it is 25 degrees centigrade, that is room temperature, and for B it is 25 degrees centigrade. Now it is 70 degrees centigrade. How it is possible? Two different bodies, but the temperature after getting same amount of heat energy is different. If the mass of these two body is same, then how do we understand what should be the specific heat capacity of them? From this equation, you see, C equals to Q by M del T. From this equation, we can say that Q we have given to both the body, it is same, because we have burned the body for equal interval of time. That means we have given same heat energy. Mass already same. So if I have taken this constants, it is coming C is inversely proportional to del T. That means C is inversely proportional to the temperature difference. Achha, see, whose temperature difference is more? Definitely the temperature difference is more for body B, and temperature difference is less for body A. Here the temperature difference is 25 degrees centigrade. Here the temperature difference is 45 degrees centigrade. So if the temperature difference is more, you see here, by getting same amount of heat energy, If the change of temperature is more, we can say that your specific heat capacity should be less, because it is related in inversely proportional order. And if the temperature difference is less, that means your specific heat capacity should be more. So by that we can conclude that if the temperature difference is more by getting same amount of heat, then specific heat capacity is less. Okay, if temperature difference is less, then specific heat capacity is more. So we can say that, in another word, to increase same amount of temperature, we have to give more heat energy of a body whose specific heat capacity is more, and whose specific heat capacity is less. Then if I give less amount of heat energy also, then its temperature should be changed more. Okay, and that is the physical significance of specific heat capacity. In generally, the conductors of heat energy have less specific heat capacity. Whatever the conductors we have seen, mainly I am talking about the metals. See, their temperature increases very fast. We all know that. The temperature of the conductors increases very fast. You see, any metal rod, if you put inside the fire, very soon you will feel that where you have hold the rod, it will be hot. You cannot able to hold it for a long time. But instead of it, if you have taken an insulator, then the temperature difference is less. So we can say insulators have more specific heat capacity. In short, if I want to explain it in one word, that the bodies or the substance whose specific heat capacity is less, they can able to change their temperature by getting less amount of heat energy. Means these are conductor, you can say copper, you can say iron, so they can change their heat energy very fast. Whatever the heat energy you can give, and directly they absorb it and change their temperature, whose specific heat capacity is less. That is called a rapid change. Okay, we can say it is rapid change. Rapid change in temperature. And if the specific heat capacity is more, then it will take much time to change its temperature. Means to increase same temperature, it will absorb more heat, and for case of less specific heat capacity, it will consume or it will absorb less amount of heat to change the same temperature. You can say, you can see the example here. Assume both of them taken a heat of 200 joule, but A, its temperature is increased only 25 degrees centigrade, but for B it is increased by 45 degrees centigrade. Then specific heat capacity, that is CB, is less than Ca. Okay, whose specific heat capacity is less, its temperature change is more. Whose specific heat capacity is more, its temperature change is less by absorbing same amount of heat. Okay, I just want to explain this thing because you have to understand what is the physical significance of specific heat capacity. Otherwise it is, you will think just it is a constant. We want to make an equation, that's why I have taken a constant, but it is not like that. It is not only a constant. Based on this constant, many more idea is left. By seeing the value of the constant, we can able to understand that how the body will behave when the heat energy is given to it. Okay, I think it is clear enough. Here I have shown you some example of specific heat capacity. If I am talking about water, you see it is 4200 joule per kg Kelvin. For copper, it is 399 joule per kg Kelvin, and lead, it is 130 joule per kg Kelvin. So by seeing the specific heat capacity, what do we understand? The water, if I'm talking about water, you see here the specific heat capacity is maximum. So for raising the temperature in water, you have to give more heat energy, or you have to give maximum heat energy, as its specific heat capacity is more. If I'm talking about copper, its specific heat capacity is less than water. So less than water means it will absorb less amount of heat energy than water to raise same amount of temperature. So we can say less heat than water. And if I'm talking about the last one, his specific heat capacity is very less. Okay, so we can say it is almost the least one for lead. Okay, and that's why its heat energy, it will just take the least heat among all. Okay, so to increase same amount of temperature, keep that thing in mind. Here we are increasing same temperature increase. It will take maximum heat, water, it will take less than water, and it will take minimum. So by seeing the specific heat, we can able to conclude that which one will absorb more heat, which one will absorb less heat, and which one is the least one. Okay, so this is the idea of specific heat. Not only that, one very interesting thing is that if you take different states of same substance, that means we know water, we know ice, it is one state of water, that is the solid state, and steam, three states of same substance. Its specific heat is 4200 joule per kg Kelvin, but for ice it is 2100 joule per kg Kelvin, and for steam 460 joule per kg Kelvin. Three states of same substance, but they have different specific heat capacity. So by seeing it, we say that specific heat capacity is the characteristic property of a substance. It depends on its intermolecular structure. Intermolecular structure. We know as the states are changed, the intermolecular structures, the intermolecular force of attraction, all the things are changed. Okay, and that's why the specific heat of the substance is also changed. Okay, so that is the physical significance of specific heat capacity. Just now we have discussed about the physical significance of specific heat, and from there we have learned for high specific heat substance, here it have to absorb huge amount of heat to change the temperature. We have just learned also the specific heat capacity of water is 4200 joule per kg Kelvin, which is very high. Now, as the specific heat capacity of water is very high, so what benefit of it we get? Here I have written the natural phenomena and the consequences of high specific heat of water. Number one, climate near the seashore is moderate. We have read geography, and in geography it is several times told that nearer the sea zone, nearer the river zone, the climate is very moderate. Why? If I'm comparing it to a zone, like if I'm talking about Rajasthan where too much sand is there, if I compare, their climate is not moderate. Okay, at morning it is too hot, but at night it is too cold, because the thing is, the reason is that the specific heat capacity of sand is very less. So that's why it can change its temperature by absorbing less amount of heat. So that's why by taking less amount of heat in morning, its temperature is very high. Okay, and at night also it can release heat energy very faster, and it seems to be too much hot and too much cold in the difference of day and night. But when we are talking about nearer to the sea or nearer to the river, there water is there, so the heat to change the atmospheric temperature, the heat is needed that is very high. So by huge heat absorption also, the temperature change is minimum. By absorbing huge heat, the temperature change is minimum. So that's why at daytime it is not too much hot, and at night also the release of heat, that is also very less, as we have seen the specific heat capacity is very high. So that's why the climate is moderate. Not only that, we know in nearer to the seashore, the land bridge and sea bridge is there respectively at day and night. Okay, night and day, I'm sorry. So here the atmosphere be moderate due to the higher specific heat capacity of water. Coming to the next one, whenever we have got injured or hurt by playing or by some work, there sometimes it is advised for us to get hot water for fermentation. Okay, so why we are using water as a substance to for fermentation? Because if you make the water, to increase the water by giving heat energy to it, the heat should be sustained for a long time. It shouldn't be cold very faster, as its specific heat capacity is very high, and that's why it is very important for fermentation. For a long time it become hot, and that's why you can take it for a long time. Next one, it is also very important. In many industries, the instruments, the machines are going on day by day, or if I'm talking about the vehicles are moving, the engines are hot after using for a long time. So there some substance is needed for coolant, which make the instrument cool, because you know, if more and more heat energy is produced in the instrument, then the lifespan of the instrument, it will be decreased. So which one should be taken as a coolant? In the case of water, it is taking as a coolant substance, because it can able to cool an object by not increasing its own temperature. As its specific heat more, so it can absorb huge amount of heat energy, but the increase of temperature is very less. Huge amount of heat energy intake, but temperature change is very less. So that's why it is used as a effective coolant, not only in general industry. If I'm talking about nuclear power plant also, there are also the water is used as a coolant. So very interesting thing here. Next one, cold countries assume where temperature goes below 0 degrees centigrade. So there, if you take the vegetables, so in vegetables, you know, inside it there will be water. So this less temperature, the water is converted into ice. So the vegetable freezes. The another food items, fruits, juice, it freezes at the temperature less than 0 degree. Then what they do? Oh, in cold countries, they keep all that things inside the water. So water is taken there as a reservoir. So if you put all the things in water, so we know the water cannot be freeze so faster because the amount of water is more. It have to lose a huge amount of heat energy, which is difficult. Okay, mainly it is happened at night. Okay, because at night the temperature falls very fast. So that time all the vegetables and that food items are putting inside the water so that it is not freezed. And in morning the temperature is increased, so you can easily use it. So here in cold countries water is used as a heat reservoir. In cold countries, one more interesting thing, the farmers used to fill the field, okay, where the food grains have been plowed. They fill the field by water. What is the reason behind that? That the small plants I'm talking about, in the plants we all know there are waters are there inside it. So as the temperature decreased, the water can able to convert into ice, and as it converts into ice, very interesting thing, you know, there is anomalous expansion of water. So as the water freezes, its volume increased. Okay, and that's why ice can able to float in water. So for this reason it is filled with water so that the temperature should be moderate, because if you want to freeze whole the field, you need to take huge amount of heat energy, which is not possible. And that's why the temperature of the plants remain moderate. And what I'm talking about earlier, if it is filled, if it is converting to ice, as its volume is increased, so the cell inside that will be burst. Okay, the cell will be burst as its volume is increased. So to prevent it, the farmers used to protect the crops by fill it water. If I'm talking about the plants and animals, 90% of our body is filled with water, so that the heat soothing capacity is very much in a plant and a animal also. Okay, so for that reason, to absorb huge amount of heat or to give huge amount of heat to our body, it doesn't make so much change, as our body is fully, almost fully filled with water. Okay, last one, in equator regions. Okay, in equator regions, as we know, the temperature is very high. So at the time of afternoon or evening time, the water used to spread over the road. You have seen in around ourselves also. The water is sprayed over the road. The reason is that due to the huge temperature at morning or at noon, the temperature is increased of the road is very high, and as you give water over there, then the temperature will decrease, because water can absorb huge amount of heat energy from the road, and that's why the temperature around ourselves, it is little decrease, and that's why the water is sprayed. So you know, you see here, due to the high specific heat of water, it can be used for huge purpose, many a purpose it is used. So then you can say, if any substance whose specific heat capacity is low, whether it can be used also. Yes, it is also used. It is also used in many purpose. I have told, for metals, if I am talking about, in metals, the specific heat capacity is generally low, but we know in many purpose we need metals. Okay, so if specific heat capacity is low, okay, then how it can be used? Number one, the cooking utensils are thick at back. Whatever the cooking utensils we have seen, as it is made by metal, so its heat capacity, specific heat capacity is low, so it can take easily the temperature by increasing temperature by getting very less amount of heat, and it can reduce the heat energy also very faster. To prevent it, because we know when we cook in some utensil, so we want that heat should be reserved there for some time to bake the food very easily. Okay, so for that case, the back of the kitchen utensils, if I'm talking about it's a frying pan, so the back of the frying pan is made thicker. It's very thick. If you feel, this back is very thick, so that as it is very thick, so it can absorb huge amount of heat energy, so that the heat should be sustained here for a long time, and then we can able to use it. That one is the use of a substance whose specific heat capacity is low. Number two, for iron, its plate is made thicker. Here is also same thing. Iron, you know, it is used almost every day. Okay. So in iron also, the portion which is being pressured, okay, over the clothes, that one is made thicker. Why? So as it is thick, so it can able to hold the heat energy for a long time. And one important thing is also there, that here we cannot able to use any another substance whose specific heat capacity is more, because here we need metal. So metal is having less specific heat capacity, then how can we able to use it? We have to make it thicker. Okay, so more thick means more mass. More thick means more mass, and we know that Q equals to mc del T. So more mass, more heat energy, whatever the specific heat capacity may be. So we can able to take or able to make huge heat energy by it. Number three, and number three we have discussed, or we, if I have not discussed, we will discuss it later, for calorimeter. So calorimeter is an instrument, we will learn a little later, that it is made up by copper. Okay, what is the reason for made it by copper? The reason is that copper, its specific heat capacity is very low. Okay, 399 joule per kg Kelvin. For water you see it is 4200, and for copper it is 399 joule per kg Kelvin. So as the specific heat capacity is less, so it can able to change temperature by getting very less amount of heat. Okay, by getting very less amount of heat, it can able to change the temperature. In the next part, when we will discuss calorimeter, then you will understand why we need less amount of heat to change the temperature. Otherwise, if you take huge amount of heat, so assume it's an instrument, assume the instrument is taking huge amount of heat, then it is difficult to get the exact heat energy absorbed by any another body. We want to find the heat energy of any another body, but if the instrument absorb more heat, then we cannot able to do it. So that's why the specific heat capacity of copper is low, and that substance we have taken so that it can take very less amount of heat to change its temperature. Okay.